Right, so this is science paper 1 representation. So in this video, I'm going to revise with you mass and weight. So by definition, mass is defined as the quantity of matter in an object. The quantity of matter in an object. And usually mass is measured in kilograms. It is measured in kilograms, or the SI units of mass are kilograms, denoted by kg. Then weight is defined as the pull of gravity on an object. The pull of gravity on an object. And usually weight is measured in newtons. Denoted by capital letter N. Okay, so the question is saying figure 1.1 shows a water skylar put horizontally across the water surface. Figure 1.1 shows a water skylar put horizontally across the water surface. So the mass of the water skylar is 60 kgs. The gravitational field strength, G, is 10 newtons per kgs. Then the first one, which is question A, is saying, calculate the weight of the water skylar. Calculate the weight of the water skylar. So now, since I know that weight is equal to mass multiplied by gravity, which is G, the gravitational field strength. So now, since here I'm calculating what? Weight. So I'm going to say weight is equal to, which is W, is equal to the mass of the water skylar, which is 60 kgs multiplied by 10 newtons per kgs, which is the gravitational field strength. Then the answer is going to be what? 600 newtons. 600 newtons. Then as for question B. Question B is saying mass and weight have different units. Mass and weight have different units. State two other differences between mass and weight. So in this question here, they are saying state two other. So which means they are excluding the units, okay? They are excluding the units. So if you put the units here, by saying mass is measured in kilograms, whereas weight is measured in newtons, they are going to mark you wrong, because they have already given you here, okay? So the first one I'm going to say, mass does not change. Mass does not change. It remains constant, whereas weight changes from place to place. Mass does not change. It remains constant, whereas weight changes from place to place. And then apart from that one, I'm going to say mass is measured using an instrument, beam balance or triple balance, whereas weight is measured using an instrument, spin balance, using an instrument, spin balance. Then the last one, you can talk about the definitions, you differentiate, okay? By using what? The definitions, you can say mass is the quantity of matter in an object, whereas weight is the pull of gravity on an object. That's all. Okay. Then as for C, C is saying a boat pulls the water skylar to the right with a horizontal force of 50 newtons. The water skylar travels at a constant speed. Now, for something to travel at a constant speed, which means it is traveling at a surface where there is frictionless, okay? Yeah. Apart from that one, where you are having unbalanced forces. So Roman numeral 1 is saying explain in terms of the horizontal forces acting why the speed is constant. So I'm going to say because of what? Frictionless surface. When you say frictionless surface, it is a surface with no friction. and friction is defined as the force which opposes the motion. The force which opposes the motion. So if you are going to the right direction, the friction is going to go here. On the left direction, that is what? Friction. So, frictionless surface. Then apart from frictionless surface, I'm going to say because of what? Unbalanced forces. When you're having unbalanced forces, let's say for example you are having 100 newtons acting on the right hand side and also 60 newtons acting on the left side, you're going to find that the resultant force is going to be what? 40 newtons. When you say 100 minus 60, then the answer is going to be what? 40 newtons, which means the object is going to move to the right direction. Okay, so because of what? Unbalanced forces. Then the last one, which is Roman numeral, what is saying, the horizontal force acting to the right increases from 50 newtons to 70 newtons. The sizes of any other forces are unchanged. Then the question is saying, calculate the acceleration of the water scalar. So before I calculate the acceleration of the water scalar, here they are saying the force is acting to the what? To the right increases from where? From 50 newtons to 70 newtons, which means here I need to find the resultant force. Okay, so resultant force is equal to 70 newtons minus 50 newtons. Then the resultant force is going to be what? 20 newtons. Okay. So in this case here, for me to calculate the acceleration, I'm going to take what? 20 newtons. Since 20 newtons is the resultant force. So now since I know that force is equal to mass multiplied by acceleration, okay? Force is equal to mass multiplied by acceleration. Then the mass of the water scalar here, it is what? 60 kg. So I'm going to say 20 newtons, which is the force, is equal to the mass, which is 60 kg multiplied by acceleration. Then since I'm finding acceleration, which means I'm going to divide by 60 kg divided by 60 kg. Then the answer is going to be, for the acceleration, is going to be what? 0.3333. Okay, so let me just round it off. So I'm going just to say 0.33 meters per second squared. So that was the last one. Thanks for watching, and remember to subscribe to my YouTube channel.